Thanks for your time today, joining with us. This is our second year of joining with Micron, and we're very excited to partner with them on their IQ partner program. The aim today is really to highlight how Micron's new 176-layer 3D NAND technology is enabling us to, and coupled with Greenliant's in-house controller development, is allowing us to develop basically solutions for industrial SSDs in demanding environments. So specifically today, we're going to look at the challenge of specifically high-resolution video recording in particularly harsh environments. So we're going to look briefly at the application requirements. So we're going to review the generic application requirements for video recording, obviously high data rates, etc. Going to look at the technical challenges that are relevant in doing this in a harsh environment. So it's easy to record video when you're in a nice temperature-controlled room, but if you're outside in the real world, or if you're down a borehole or top of a mountain, things become a lot more challenging. So we're going to describe how those technical challenges can affect the solution, and also what we can offer with Micron for SSD solutions for these type of applications. Okay, so obviously the first thing to think about in recording video is high bandwidth. So the application and the case study we're going to look at today requires a very high bandwidth. But if you don't require that high bandwidth, then it's probably a good idea to look at something like SATA, which will give you a big advantage in power. So if you don't have super high bandwidth requirements, look at a lower power solution like SATA. But if you do, then NVMe over PCIe is the way to go. Greenliant specifically focuses on industrial temperature range, an industrial temperature range operation, and that's crucial in this type of application. You can imagine camera, again, maybe it's in the north of Finland in the winter, or it's sub-Saharan Africa. You need full industrial temperature range operation, -40 to +85 in this case. And you need stable performance over that temperature range. So it's no good, it works great at 70 degrees, and then as the temperature increases, self-heating starts to take over, and the device goes into some kind of low power, low performance mode. So it's got to be stable over that entire temperature range. And we also need low and consistent latencies. You need to be able to write to the device, read from the device, and not have any problems with that. And high data integrity. So that's kind of like should be a given, right? But this is Greenliant's #1 issue is high data integrity. So your data is our most important thing, and we go to great lengths to ensure that data integrity is maintained. Large capacity, obviously, in a video recording application, you're going to need multi-terabyte application, multi-terabyte storage. So that, again, is another key requirement. So the generic application we're going to look at here is, in this application, something like a vehicle, a bus, or something that is out in the real world. The recording requirements are obviously that you can store multiple HD streams. You might have video outside of the vehicle, you might have video recording inside the vehicle. So you need to be able to cope with multiple high-performance data streams. And they may be, MPEG-2, 2 megabit kind of data rates, or it may be up to, 8K storage. So you need a lot of storage capable. You need consistent data rates. So you've got to be able to store that constant stream of data. So it's no use saying, we're running out of bandwidth, shut down that video camera, so we can manage these other streams. You've got to be able to manage all of the streams all of the time. And you need load, read, and write latencies so that you can actually display the data at the same time as recording it. So product requirements, obviously high capacity storage. You need a lot of storage. We're showing two 8 terabyte drives here. One SATA, one NVMe. So high capacity storage is crucial. Low power onto ready time. So that may not be obvious as to why that's important, but if you think about, you turn the ignition on your bus, drive out the door, you have an accident. Oh, the recorder's not started yet. Or something happens in the back of the vehicle in the first couple of minutes. You've got to be ready to store the data from literally from that ignition on moment. Industrial temperature range, we already talked about, absolutely crucial, and power fail protection. So this comes together with the requirement for those low power onto ready times. So we'll talk about that in a minute, but power fail protection, absolutely crucial in a vehicle environment. So high temperature operation, what are the key requirements? So with NAND, obviously, data retention time scale with temperature. When the device is active, it's not such a big issue. You've got active data retention going on the drive, and this provides reliable operation as the drive's running. The problem comes when you turn the power off and you leave the drive. Maybe you've had an accident and the device has been put in a storage somewhere to be used in legal evidence later. So the device has to be able to maintain that storage for probably many years. Now, it's not immediately obvious, but endurance matters in that application. So if you have a high endurance drive, that means you get longer data retention with the power off. So again, one of the great things with Micron's 176-layer 3D low-power NAND is that you get very high endurance rates, and we can offer up to 30 drive writes per day for 5 years endurance on these drives. And that obviously means that if you've used less of the endurance of the drive, you've got longer data retention when the power's off. And we've got a little diagram down at the bottom here about the current NAND versus the new generation NAND. Now I know I'm not capable of explaining this, but I know there's guys here in the crowd from Micron that will be able to explain how the new generations of 3D NAND are so much better at low power and data retention. Bandwidth. So again, high temperature operation, the effect on bandwidth. One of the banes of a lot of engineers' lives is thermal throttling. So the effect that you put the drive in the machine, temperature starts to rise, you're running at high bandwidth, self-heating starts to take over, the drive says, "Whoa, we're getting too hot, scale back the performance." And that's not so great if you're recording video. Right? So the video's coming whether you're ready or not. So you can't afford to miss crucial surveillance data because your device has gone into thermal throttling. With a combination of our intelligent controller design and Micron's latest 176-layer NAND, we can achieve basically the whole industrial temperature range without having to run into any thermal throttling issues. And we do have thermal throttling available, but it's only once the device gets into a kind of a critical point where the device will basically destroy itself. So major benefit there of using the new NAND. And you can see there's a kind of hysteresis diagram down here showing you what happens with self-heating and how the thermal throttling works. So other high-stress environments, obviously, the power supply has a crucial effect on this. We feature power loss protection on all of our industrial SSDs, but basically we have on the industrial drives a fairly simple approach with a low voltage detector, a load switch, and then some kind of backup power reservoir, probably a capacitor or bank of capacitors on the drive. And this gives you a relatively straightforward power fail operation, which is obviously crucial in most vehicle applications. The other issue based on that is the flash file system. So Greenliant's controllers are inherently power fail safe. So you can cut the power off in any stage of the drive's operation. You will not kill the drive. When it powers up again, it will be there, the data is there, it will. Now the only issue is it may have to reconstruct some of those mapping tables. and that may take some time. So, and again, our criterion were that the device should be available for storage as soon as you power it up. So that's why the power fail protection on the previous slide is so important. So our device won't die, but it may take a few minutes to reconstruct those mapping tables. And we have customers that have tested these devices over many hundreds of thousands of operations, many hundreds of thousands of power fails. In fact, we had one customer said, we tested it for a year, we couldn't break it, and your nearest competitor died in a week. So we're very confident. In fact, Ralph Thompson, my colleague who is away, that's his favorite. He says that's the key thing about our products is the power fail protection. So, summing that up, I think we've shown successful collaboration between Micron and Greenliant has resulted in a great solution for industrial harsh environment data recording, and really it's based on Micron's 176-layer 3D NAND, which really helps us get to those performance points. That's really crucial in this application. So just thought I'd show a few other slides of some other products that we have in our locker, just in case multi-terabyte operation isn't your thing. So we start all the way down on the left there with a micro SD card. Moving through our solder down BGA products, M.2s, 2.5-inch and U.2 devices. High data reliability is our thing. So it's everything about the controller and the firmware is to give you high data reliability. So your data is our most important commodity. We also have encryption capability on many of these devices, so we can do AES 256 encryption. We also have Opal 2 available on many of the M.2 products. Because it's our controller, our firmware, we can offer we obviously offer the smart intelligent monitoring functions, but we can do much more than that. Because we can customize the smart functions to be as involved as you like. And we've obviously talked about the power loss protection. That's available on many of these products. From a firmware point of view, it's available on all of them, and on many of them have the capacitive-based solution. iTemp operation, obviously, RAID on chip. Now, this is we didn't actually talk about this in the actual case study, but our devices on the larger industrial enterprise products actually have a onboard RAID. So many people are familiar with RAID, multiple drives. One drive fails, it saves your data and runs on the other drives. But we do that across the NAND chips on the big, on the multi-terabyte drives. So if you have a NAND chip failure, internally it will reapportion the data to the other drive, to the other NAND drives, and so you won't lose data even if one of the NAND drives fails. And that will continue to do that as and when, hopefully, over a very long period of time, the NAND chips fail. So you will lose data at some point, or you'll lose capacity, but you'll never lose data simply because of one NAND chip failing on the drive. So that can be a really crucial thing. Particularly, we have many customers that are, it's not easy to get to the drive to take it out to put another one in. It might be in a satellite, it might be in a hard to get to place. We offer quick data erase, so many of the standard NSA, for instance, data erase functions, but we also do crypto erase, so erasing the crypto key can be a quick way of destroying a drive. And as we talked about again, long data retention based on those high endurance values. And something that actually isn't on this foil is long-term availability. So one of the key things, again, all of our customers are industrial. We make these products available for absolutely as long as possible.